This is Mr. Beck Does Your Homework. This is homework AP Physics number 4.1, question number 6. It says a car is moving at 16 meters per second along a curve on a horizontal plane with a radius of curvature 48 meters. So what I've got is I've got this circular path. I've got a car. Let's draw it coming at me. So here's my car coming at me. And this car on its tires, it's moving with a radius of curvature of 48 meters. There's my R. The acceleration of gravity is 9.8. I might be interested in that. What is the required minimum coefficient of static friction between the road and the car's tires to keep the car from skidding? Doesn't seem like I have much information there. I don't have the mass of the car. I do know the speed. It's moving at 16 meters per second. And I do know the radius is 48 meters. So I don't know what, so what's going on here? Let's take a look at that car. When I look at that car, so here's my car, there's my tires, my headlights, my front of my car, maybe a windshield or something. What are the forces on this car? I have a force of gravity. I have a normal force. And what other force? Well, in order for it to move moving in a circle, it has to have some force pointed towards the center of the circle. So that's centripetal, but where is that force coming from? It turns out that it's between the tires and the road. If there's no force between the tires and the road, the car would go off in a straight line. Instead, the car makes it around the turn. So this is my force friction. So what I know is that this is going to be my centripetal force. So that tells me that my force friction is going to equal mv squared over r. Well, I'm looking for m, so m is going to be my force of friction times the radius divided by velocity squared. But what's the force of friction? And I don't know my mass here. I'm looking for what's the minimum coefficient of static friction. So that's the mass that I don't know. Now I know that my coefficient of static friction is going to be my force of friction divided by my normal force, right? So actually, I'm going to skip this step that I was taking before, so ignore that for a second. My force of friction is mv squared over r. So that means mu is going to be mv squared over r divided by the normal force. Well, what's the normal force going to be? It's going to be the same as gravity. So my force normal here in this case, because I have no monsters, is going to be the same as the force of gravity is going to equal mg. So if I take this force of friction divided by the normal force, well, that's the same as 1 over mg. So what I get here is that my coefficient of friction is going to be mv squared over r mg. Well, look at this. Mass cancels out, so I don't need the mass. So it turns out that my coefficient of friction is going to be v squared over rg. And that is the mu that I'm looking for, and I happen to know all of those. I know the speed, I know my radius, and I know the acceleration of gravity.